Hey, I'm LP Wilson. Today we are going to learn how to do Lesson 14 in Code.org CS Discoveries Unit 3, Coding Animations with Conditionals. So if you've never heard of conditionals, never done this before, want to finish Lesson 14, any of those, this is the place for you. First, I'm going to give an intro of conditionals. With conditionals, you can make a program like this. Up till now, we've had a program that once it starts, it continues doing the same thing. But now, we can have the program change throughout. Okay. Now, the vocabulary might sound confusing at first. It was for me the first time. But the effect in the computer is actually going to be a little bit straightforward. So don't be scared. For this program, I've got my normal setting up of the sprites, background magenta. I've got a unicorn moving smoothly across the screen using the counter pattern. The only thing that's different is this block right here. Without it, this program just sends the unicorn across the screen. With this new block, it says if the unicorn's x is greater than or equal to 200, unicorn.setAnimation, sticker 12, that's the cat animation, and unicorn.x gets 200. Basically, we're telling the computer, hey, once the unicorn is halfway across the screen, turn into a cat and stay there. Okay, let's break this down. First, a little bit of vocabulary. All right, conditions and conditionals. Everything on the screen right now is an example of a conditional. We do conditionals all the time. We can say, for example, in my class, I'll ask students to say, if you're older than 11, type your favorite TV show. The condition of this is you are older than 11. And the conditional is the whole statement. If this, do this. This is the syntax, the language that we're going to be using to the computer, more or less. Hey, computer, if this, do this. So check out this vocab. A condition is something a program checks to see whether it's true before deciding to take an action, and a conditional is a statement that only runs under certain conditions. Okay. Feel free to pause there. Other things you're going to need to know. This is everything you need to know for Lesson 14. How do you read this aloud? Get out of the way, Mix Wilson. 5 is greater than 1. Okay, greater than, less than are going to be important in this lesson. Also, computers, often this sort of statement will be read like a yes or no question. If X is less than Y, do this. This is one way of reading out loud what the computer is processing. If this, do this. Okay. And question for y'all. If 3 is less than 5, draw a square. Okay, if I tell this to a computer, will the computer draw a square in the language a computer can understand, coding? Yeah, absolutely it'll draw a square because 3 is less than 5. Okay, just wanted to start with some more simple examples before we jump into it. Okay, enough chitter-chatter. Let's go to Lesson 14. Okay, in this lesson, the videos are very helpful. So the diamond videos, which you can see in Bubble 3 and Bubble 7, are really great. So I do recommend checking those out. The first level is a predict level. Okay, so it says predict. Read the code below. There's some new symbols in it which you haven't been introduced to. Take a guess at what they mean and try to answer the following question. Which result will be printed in the console by this program? And we've got some choices. We've got true, false, true, 0, 200, 100, true, error, true, false, true, false. Let's break this code down. So this is Lesson 14, Bubble 2. It starts by creating 2 sprites. Sprite 1 has an X value of 100 and a Y value of 200. Sprite 2 has X value of 300, Y value of 200. You have to predict what each command will print. This console.log, all that means is print something down here. So console.log, sprite 1's Y, is it equal to sprite 2's Y? do these two sprites have the same y? This one's asking, is sprite 1's x greater than sprite 2's x? And this one is asking, is sprite 1's x less than sprite 2's y? So take your time, take a guess at that, answer A, B, C, or D, then click run. Okay, go ahead and pause while you do that. Good job. Okay, I want to show you a few things in this video. New definition. A Boolean expression is an expression that can only evaluate to true or false. Super useful. Also here, and again, this is Felicia Williams, software engineer at Facebook, walks us through this. This symbol means checks if these two values are equal. This one checks if the left is greater than the right. And this one checks, get my face out of the way, if the left is less than the right. And each of these statements will evaluate to either true or false. So they are Booleans. The computer, when it sees 1 less than 2, it says, hey, that's true. And all that matters to the computer is that that's true. And now it just acts like the word true is there. And that is, again, like the computer's way of saying yes to a yes-no question. Okay, once you've watched that video, let's move on to number 4. All right, so in number 4, we get to mix and match these English phrases with the coding phrases. I'll do one for you now. Definitely good to take your time, get this one right. It is really helpful to be able to convert the coding language into English. All right, so the first one says, is the dog sprite's rotation less than the cat sprite's rotation? Okay, so looking at these, do we see one that says rotation? Yeah, absolutely we do. So this is the right place for this because dog sprite rotation is less than cat sprite rotation. Okay, and then you'll keep going like that, remembering that this sign means greater than, and this one means less than. Alrighty. Okay, now pause if you need to catch up. In this one, the program draws a race car and a finish line. We're going to figure out when the race car crosses the finish line. The sprites have all been set up for you. Our goal in this problem is to get at the bottom of the screen in the debug console for it to say false a bunch of times when the car has not crossed a finish line. We want it to say false, 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 false. And then as soon as it crosses, for it to say true, 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 true. This is our way of checking if the computer understands when the car has crossed a finish line or not. So we're just going to follow the instructions in the do this section. So it says add a console.log statement inside the draw loop. Show me where. Okay, right there. Great, console.log is in the purple variables section. I click and drag it and put it here. All right. Then it says add a Boolean expression inside the console.log that asks, is the x position of the race car less than the x position of the finish line? What we're doing is kind of like in the last bubble. We're going to convert an English question into a language that the computer understands. Okay, let's do this. So a Boolean, for now, our Booleans are going to be these, a lot of times using these symbols, is equal to, greater than, or less than. And if you hover over them, it'll remind you what they are. So we want to see, is the x position of the race car less than the x position of the finish line? Okay, well, I'm going to use the less than operator and put that in this blank that currently says message. Okay, and I want to put x position of race car. Well, that sounds like racecar.x to me. So go to the red sprite section, take sprite.x, put that there, and then type in race car. Make sure you match the capitalization that we see here, so capital C for car. All right, is the x position of the race car less than the x position of the finish line? Okay, I'll do sprite.x again and do finish line with a capital L, just like it's written there. Finish line.x. Okay, we're going to test it. You look down here and see if it says false, 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 true, 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 true. Okay, good. False. And true. Excellent. Okay, cool. Good job. So this line is the one we needed here. Yes! Beautiful. Okay, bubble 6 is another prediction. Okay, Boolean expressions allow us to ask questions, but in order to use those questions to change the program's behavior, we need an if statement. Here's the block, the magic block. If. Haha. Do this. Read the code for this race car program. What will the program do if the car reaches the finish line? Why is the if block inside the draw loop? Okay, let's check it out. So inside the draw loop, we have the race car X gets race car X minus 2. That's going to make our race car move smoothly across the screen. If race car X is less than 100, console.log says winner. Okay, so think about what's going to happen. What is going to happen when the race car's X gets to 100, somewhere over here? Okay, let's see. Predict first. Okay, we're going. Winner! Now it says winner a bunch of times. It's putting winner in this console log every single time the draw loop is run. So think about why is it inside the draw loop? Well, maybe because we want the computer to always be checking if the car has passed the finish line. Yeah, it's always checking if the car's passed the finish line. That way it can tell us exactly, or as close to exactly as it can, when the car gets to the finish line. All right, moving on. Okay, I recommend watching this video in Bubble 7. Let's go over the key points. Again, Felicia Williams walks us through conditionals. And the example she gives is if it's sunny, you might wear sunglasses. If it's raining, wear a raincoat. We use conditionals all the time. Alrighty. And in this video, she also gives a great example of why you might want to use the greater than sign rather than the equals sign. If you're going to give someone a bonus once they get to 100 points, you want to have a greater than sign for that. And she here shows the example, just like I showed you at the beginning, of how to get a sprite to change its animation past a certain point to turn into a race car. Okay, once you've watched that, we're going to go on to Bubble 8. I love this one. Okay, in Bubble 8, it says, use a conditional in the draw loop to check whether fruit.scale is greater than 2. If it is, change the fruit's animation to pair. So we want to make this code go so that when this apple gets to scale 2, then it'll change to a pair. Down here, you can see the fruit scale and see when it gets to 2. Okay, I'm going to give you a couple hints to get started. Then I'll show you how to do it after you pause. So in the control block, grab a blue if statement. Put that in the chat. And we want to check if the apple's scale is bigger than or equal to 2, or just bigger than 2. If the apple scale is bigger than 2, then turn it into a pair. You're going to need to use something from the orange math section. Okay, you should pause and try it. Ready, pause. Okay, cool. So hopefully you said, okay, I want to check if it's greater than. So I'm going to use a greater than. What am I checking? Well, I'm checking fruit.scale. So I can pull in a sprite.scale, type in fruit, and check if it's bigger than 2. what should we do if it's bigger than 2? Turn it into a pair. And at first I thought, how do I turn it into a pair? It's already an apple. Actually, all we need is this sprite.setAnimation block. Fruit.setAnimation pair. Okay, let's try it. You can watch the fruit scale grow here. Okay. Da, 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 da. We did it. We are amazing. Good work. Go ahead and pause if you need to catch up on this. And let's go to the next one. All right. A lot of great activities here. Today, I'm going to show you how to do B and C. I do recommend trying these on your own first. You can totally handle it. This one, I want to make the soup spill out of the bowl when it turns upside down. Okay, cool. Now, the code we're going to use for making the soup spill out of the bowl is actually just to change the animation, because there is a animation that's called bowl that is an empty bowl. So we're going to have it start full and then switch animations. Okay, pause and try it. Ready, pause. Good work. Okay. I'm going to use the if block and check if the sprite's rotation is bigger than a certain number. And you can just type it in, soup.rotation. Okay. And if the rotation is bigger than a certain number, we'll switch the animations. The rotation is in degrees. There's 360 degrees in a circle. I'm just going to say 150. That's almost halfway around. So if the rotation is bigger than that, we're going to go to the animation that is the bowl. Let's check it out. Hey, not bad. You can choose if you want the soup to fall out earlier or later by changing this number 150. Okay. Pause if you need to. See you back at number 9. Okay, alien celebration. This one makes me so happy. Okay, for this one, we have to add a conditional that detects when the spaceship is in the sky and sets the sprite's animation to alien dance. And it's got a little helpful comment here. It says, when the spaceship reaches the top of the screen, set the alien's animation to alien dance. Okay, so we go to the blue control section. Oh, try it first. Good. Blue control section. If block. Boop. Okay. And then if the spaceship's Y, spaceship period Y, is greater than, I'm going to have a bug in this. You're going to help me fix it. Let's say 100. Alien dot set animation. Alien dance. Okay, now get ready. I think there's going to be a bug. See if you can help me fix it. Oh, he's dancing. Okay, he started dancing right away. I don't want him to be dancing until he gets to the sky. Pause, see if you can figure out what it did wrong. Okay. In this one, I forgot that Y gets smaller as you go up. The spaceship's Y is getting smaller. So I need the less than operator here. Goodbye. Grab that less than sign. Nice. Spaceship.y less than 100. Okay, let's test it now. Standing, dancing. Yes, I'm going to watch it again. Great debugging, everyone. Okay. Phew. Once you've done those, you can pause here if you need to. We're going to go to the purple level, the assessment level. This one is really similar to the one before it, actually, y'all. We want, once the dinosaur gets past a point in the sky, we want his animation to change. Okay, let's go. We go to control. We take the blue if block. If it gets to the sky, turn it into a pterodactyl. I know to turn it into a pterodactyl, I'm going to be putting this here. Dinosaur dot set animation pterodactyl. Okay, I'm going to leave this to you. Your next hint is to go to the orange math section and think about which one do you need, a less than or a greater than. we're going to use dinosaur.y and one of these symbols. You got this. Okay. That's it for me. Thank you so much for watching. Good luck. Bye.